The last one, and I'm actually going to do this two ways. So I'm going to show you two ways you could solve this. So the first way, I'm going to stick with the quotient rule and the chain rule method because I think that's the easiest. But there is an alternative to that some students like to use, and so I will show you. So my method one, I'm going to use the quotient and the chain. Alright, because when I rewrite this, I've got the division of the x plus 1 and the 2x minus 1 to the power 1/2 because the square root's written as 1/2. Alright, so the quotient rule, the chain rule on my bottom function. Alright, so first is the low function, 2x minus 1 to the 1/2, times the derivative of the high, which is a nice derivative, it's just 1, minus the high, make sure you put parentheses because it's minus the whole top function, so parentheses. The derivative of the low, which is going to require my chain rule, so let's pull out my 1/2, raise it to 1 degree less, which would be the negative 1/2. Not done yet. Remember, that's just the outside. Take it times the derivative of the inside. Derivative of the inside is 2. And then it's that whole thing squared, the denominator squared. All right, so now this mess, the hard part, this is a tough one. This is a tricky one because we've got fractions and negative powers. All right, first of all, this half and this 2, those reduce to 1. All right, 2 divided by 2 gives me 1. All right, now comes the tricky part. Factor out the common group. All right, they do have a common group, 2x minus 1. And you always factor out the lower power. All right, that's the same thing we did in the last example, but this one's a little trickier because you've got the fractional powers. All right, and then this also reduces to 1. Okay. So now to factor out, maybe I'm going to rewrite it, cleaned up a little bit before I do my factoring. All right, so up top, this is 2x minus 1 to the 1/2 minus x plus 1 times 2x minus 1 to the negative 1/2, right? I simplified the 2 and the 1/2 there, and then this just simplifies to 2x minus 1 to the first. All right. There's factoring out that group that they share in common. All right, I can pull out a 2x minus 1. The lower power, well, I've got a positive 1/2 and a negative 1/2. The negative 1/2 is the lower power. That's still over 2x minus 1. I can't do anything yet until I get to this step. All right, times what's left over. All right, so what's left over, remember, factoring means I'm dividing out. So it's actually easier to talk about the second term first. All right, we're going to do that one first. So I pulled out the 2x minus 1 and negative 1. That group's gone. I factored it out. Pulled it out to the front. And so in the second term, all I'm left with is the negative 1 times the x plus 1. If you remember my statement before, there should always be one of my groups left over. And there is. In this first term, I'm pulling out a negative 1/2. Well, it's a positive 1/2. So when I'm pulling it out, I'm dividing by that. And so really I'm taking a negative 1/2 divided by, or positive 1/2 divided by a negative 1/2. And so what's left over is one of those. And the easiest way to understand that is, remember, when we factor, it's undoing the multiplication. If I multiply it back, I should get this original term, right? If I take this group times this group, I get back to my positive 1/2, right? Because this would be a 1 here. I take my negative 1/2, add it to my positive 1, and that's going to give me a positive 1/2. And so when we pull that out, that's what we're left with. And the rule of thumb is we should always be left with one group of whatever it is I took the chain rule on. And I am. I've got one of those groups in this first term. In the second term, I'm left with the numerator, right? The high function, which was x plus 1. Right? And there's the factor step. Right? That's the tough step. Another way, and I'll kind of go over, just explain this a little bit better over here. So this is sort of off to the side work to kind of explain how this is happening. when we're factoring, so up top I had that 2x minus 1 to the 1 half minus x plus 1, 2x minus 1 to the negative 1 half. When we're factoring, what we're literally doing is dividing out. So when I pull this out front and I factor it out, what you're doing, we call it factoring, is where we're dividing it out. So I divide this out by 2x minus 1, which is why it's gone. And I divide this by 2x minus 1. Right, that's what we're doing inside the brackets. Make them a little bigger. And so that's why this reduces to 1. That's gone, right? If I divide by the same expression, that equals 1. That's why I'm left with just an x plus 1 there. This one, I'm dividing out, and when I divide by the same base, right, I have the same base, 2x minus 1, I subtract my exponents. What would be 1 half minus a negative 1 half, which adds up to 1, and that's why we kind of get 1 left there. So that's, again, sort of explaining how we get the expression that we get here. All right, again, the easiest way for me to sort of figure out is we should always be left with one group. All right, so that's the hard step. That's the tricky step. Now the simplification. Well, this, I need to distribute my negative 1 here and then collect like terms. This can be moved down here because it's a negative exponent. All right, so up top, I've got 2x minus 1 minus x minus 1. In the bottom, I have 2x minus 1 to the 1 half, because I moved it down, it becomes positive. 2x minus 1, right? That's what, I move this step down, so when I move it down, it becomes a positive 1 half. All right, the last thing is to just clean this up. So up top is collect like terms, so I'm going to have x minus 2. And in the bottom, I can add my exponents. I have 1 half of those here and 1 of them there, and so that means I've got 3 1/2 groups left over. And there is that expression, completely simplified. Like I said, this is a toughie. If I were to ask this on a quiz or an exam, I would probably make this a bonus question. But it is something you should know how to do. Alright, so there's my expression. Alright, so that's method 1. Alright, method 2, which I'm going to give myself a little more room to work. Apparently I didn't give myself enough room. Alright, so start off with the same expression. So my original f of x, which was x plus 1 divided by 2x minus 1 to the 1 half. Now, a different way you could do that is move that up. So if I rewrite this, x plus 1 times 2x minus 1 to the negative 1 half, because I moved it up. Well, now I'm going to use the product rule instead of the quotient rule. Alright, so product rule instead of the quotient rule. My first function is the x plus 1. My second function is the 2x minus 1 to the negative 1 half. Alright, so the first times the derivative of the second. So I pull out my negative 1 half power. 2x minus 1 raised to the negative 3 halves, right, when I subtract 1. It's the outside times the derivative of the inside, which is 2. Then it's the product rule, so I add the second function times the derivative of the first, which is just 1. Alright, so there's no division here because it's the product rule. So it's just the first derivative of the second plus the second derivative of the first. Alright, I am still going to factor out the common group, which again was 2x minus 1, and the lower power, which would be the negative 3 halves. Alright, so factor out 2x minus 1 to the negative 3 halves. Alright, negative 3 halves is smaller than negative 1 half. And then what's left over? Alright, well in the first term, the negative 3 halves term's gone. I'm left with this group, x plus 1, and then this 2 will reduce with that 2, but I do have a negative 1 I'm left over with. Alright, so I've got x plus 1 times negative 1 in the first term left over, plus, in the second term, negative 1/2 is a little hard to see, I pulled out negative 3/2. I had negative 1/2, which means those differ by 1, right? And so that means I will have one of those groups left over here, because in order to get back to that expression, I have to have one of those. Because if I multiplied back, if I had 1 here, negative 3/2 plus 1 will leave me with a negative 1/2. And so, and again, I should always, because of the way the chain rule works, I should always have one of my groups left over. And so that's where it is. And then I simplify that. 2x minus 1. Inside, I distribute my negative 1, so I get negative x minus 1 plus 2x minus 1. Oops, forgot my negative 3/2 there. 2x minus 1 to the negative 3/2. This simplifies to x minus 2. Alright, last step is to move that down, and so up top the x minus 2 stays. And I move down the 2x minus 1, and I make it a 3/2 when I move it down. And you'll see that's the exact same expression I had up here. X minus 2 divided by 2x minus 1 to the 3/2. And so, personally, I think the second form of this is easier, but you do have bigger fractional exponents you have to deal with. So you pick your poison on this one. Right? You decide which method that makes the most sense to you, you understand, and go with it. All right, we'll stop there. We're all done with the rules. All right, so until we get to logs and exponentials in Chapter 2, we've now covered all of the derivative rules that you need for Chapter 1. So that's it. Covered them all. Now you just need to practice, 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 and more practice.